In this program, we'll use the light sensor to control the color of the entire LED strip. Anytime we're using the LED strip, we want to include the ledstrip.h library. That gives us access to special functions that apply only to the LED strip, like setPixel and draw. When we're setting up the LED strip, we also need to give our strip a name. I just named mine strip because it's easy for me to remember and easy to type. We also need to complete this strip function, which has three arguments. The first is how many pixels are on our LED strip. The second is which pin of MakerBoard is plugged into the green wire of the LED strip. And you can remember this by remembering that green rhymes with 13. And the third argument is which pin of the MakerBoard is plugged into the blue wire of the LED strip. In the void setup function, we'll use the pin mode function to set port A2 as an input. This is the light sensor plugged into the smaller block of ports at the bottom of MakerBoard. Make sure that the plus and minus pins on the light sensor board match up with the plus and minus ports on MakerBoard. Within the void loop function, the first thing you'll do is create a variable. And when you create a variable, the first thing you type is what type of variable it is. This is an integer variable shortened to int, and that just means the value of the variable will always be a whole number. Next, name the variable. It's good to name variables something that's obvious and easy for you to remember, and keep in mind someone else may read your code too. So I'm just naming this variable color, because that's what this variable is going to stand in for, the color of the LED strip. After one equals sign, you give the variable its value. And this variable's value is going to come from the analog reading of port A2. The light sensor can send in a value from 0 for completely dark to 1023 for really bright. So at this point, the color variable can have a value that ranges from 0 to 1023. On line 13, we're immediately going to change the value of the color variable, and we'll do that with the map function. The map function allows us to match up different ranges of numbers, even if those ranges are of different sizes. So here, we know that the light sensor can report a value of 0 to 1023, but we know that the LED strip only has color values from 0 to 299. By using the map function, we can make those ranges match up so that a light sensor value can assign a color that we can see on the LED strip. So the first argument of the map function is what is the value that we're mapping? We're mapping the color variable. The second argument of the map function is what is the lowest value from the starting range that we're mapping. This is going to be what's the lowest value that the light sensor can read, so it's 0. The third argument is what is the highest value from the range we're mapping from. That's 1023, and that's the highest value that the light sensor can send into the code. The fourth argument of the map function is what is the value we want to map the second argument to. So this is saying when we have a light reading of 0, what do we want to convert that number to on the color range? In this case, we want to convert 0 to 0. The fifth argument in the map function is what is the value we want to map the third argument to. So in this case, when we have a light reading of 1023 on port A2, what do we want that to equal as a color value on the LED strip? We want it to equal 299. So line 13 is taking the reading from port A2 and converting its range from 0 to 1023 to 0 to 299. After this line runs, the range for the color variable is 0 to 299. On line 16, you see a setPixel function, and that has two arguments. First, which pixel or pixels do we want to light up? And we're going to use strip.all to tell the LED strip we want to light up every pixel that we have. The second argument is what color value do we want to show on those pixels? we're using the variable color here, which we just determined is ranging from 0 to 299. So this color value that's going to show on the strip has been mapped from 0 to 1023 down to 0 to 299, and now we're going to show that on the LED strip. The .draw function sends that set pixel data to the strip and displays it. When the code reaches the bottom of the void loop, it jumps back up to line 12 and checks the analog read of port A2 again, giving color a new value, and then on line 13 we change that color value by mapping it from 0 to 0 and 1023 to 299, and then we use that updated color value to set the pixels again and draw them. There are no delays inside this void loop, so this color value is going to get updated hundreds or thousands of times per second, and making a shadow or shining a light on your light sensor should immediately change the color of the LED strip.